Hello friends, today I will discuss the pitch factor. This is also called coil span factor. This factor will come into picture only when the coil is short pitched coil. The definition of the full pitched coil and the short pitched coil is like this. If the angle between the two coil sides of the coil is less than 180 degrees, then such coil is called the short pitched coil. If the angle between the two coil sides of the coil is equal to 180 degrees, then it is called the full pitched coil. The definition for the pitch factor is represented by Kp and it is equal to resultant EMF of short pitched coil divided by resultant EMF of full pitched coil. This can also be mentioned as phasor sum of coil side EMFs divided by arithmetic sum of coil sides EMFs. This also can be further simplified as vector sum of EMFs divided by arithmetic sum of EMFs in the coil. And this full pitched coil and short pitched coil can be shown in the figure like this. Coil means it consists of two conductors. Each conductor is also called the coil side. This is the conductor, that is first conductor. This is also called coil side. Similarly, there is another coil side, that is this. This is also called another conductor. Connecting these two conductors is called the coil. If the angle between this conductor and this conductor, that is between these coil sides, is 180 degrees electrical, then such winding is called the full pitched coil. If the angle between the two coil sides is not 180 but it is shorted by an angle called alpha like this, that is if the distance between this coil side and this coil side is less than 180 degrees, then it is called the short pitched coil. Then the angle between these two coil sides in the short pitched coil is nothing but 180 degrees minus alpha, like this. So in this video, the aim is to calculate the phasor sum of voltage of this short pitched coil and also arithmetic sum of voltages in this short pitched coil. In this case, each coil side induces voltage E, that is this coil side we represent as OA, and the voltage induced in this is capital E, like this. Similarly, there is another coil side that is from here to here, that is second coil side, that we represent as AD, and the voltage induced in that is capital E, but this AD will have the short pitch angle, that is alpha, like this. This is called chord angle, like this. Then the resultant of this OA and AD is represented by resultant voltage ER, like this. Then bisecting this ER from point A, then point C will be obtained on line OD. Once it is drawn, this is nothing but a triangle OCA, that is rectangle triangle. If you know this angle is anyhow 90 degrees. If you know this angle, it is possible to calculate what is ER, because this OC is equal to CD. If you calculate OC, then automatically ER can be said as ER is equal to 2 into OC. So to get this vector diagram can be further explained like this. This is the chording angle And whereas this angle from here to here, it is nothing but 180 minus alpha degrees. And this bisector we have here, the angle between, this line and this is 90 degrees, and this angle is alpha by 2, and this angle from here to here is nothing but 90 minus alpha by 2, that is nothing but 180 minus alpha by 2 means 180 by 2 means 90 degrees minus alpha by 2, like this. It is a triangle. In a triangle, total angle must be equal to 180 degrees. So when we add 90 degrees plus 90 minus alpha by 2 plus alpha by 2, then total angle will become 180 degrees. And using this triangle, it is possible to calculate what is OC. So to calculate that, find out what is the cos alpha by 2 using the triangle OAC. So in the triangle OAC, cos alpha by 2 is nothing but adjacent side, that is nothing but OC divided by hypotenuse, that is OA. OC by OA. And from this, OC can be written as OA into cos alpha by 2. And we know what is OA. OA is nothing but the voltage induced in the first coil side. So that is called capital A. So we replace OA with E, then cos alpha by 2 is as it is there. Then the ER, that is the resultant voltage, is nothing but equal to OD, which is nothing but equal to 2 into OC, that also can be written as 2 into OA cos alpha by 2. And since OC is equal to CD and OA is equal to capital A, substitute this here, OA in place of OA, keep capital E, then we get ER is equal to 2E cos alpha by 2. This represents the vector sum of the voltages in the coil, that is the numerator is obtained for calculating the pitch factor, whereas the arithmetic sum of the voltages in the coil are nothing but capital E plus capital E, that is 2E. So substituting those values, we get Kp, that is a pitch factor. Kp is equal to vector sum is obtained, that is Er is nothing but 2E cos alpha by 2 divided by arithmetic sum of the coil side EMFs, that is OA plus AD magnitudes, that is E plus E, that is 2E. Then this 2E going to get cancelled. Then we get what is called the cos alpha by 2, and this cos alpha by 2 is called the pitch factor of the short pitched coil. When the coil is short pitched, then there is possibility of harmonics present, but the expected thing is only fundamental waveforms should be there, but harmonics will be there. These harmonics are unwanted. So when the harmonics are there, in that case, the pitch factor definition will become like this: cos of n alpha by 2, where n is the nth harmonic or harmonic number. So normally in the alternator, third harmonic, fifth harmonics will be present. So when they are present, to nullify that, the alpha should be redesigned. Suppose only fifth harmonic is present, in that case cos 5 alpha by 2 must be equal to 0. So from this we can write 5 alpha by 2 is equal to cos inverse 0 means 90 degrees. So from this alpha can be written as 180 by 5, that is 36 degrees. So if the alpha becomes 36 degrees, that is carding angle is 36 degrees, in that case fifth harmonic flux can be avoided. Similarly, suppose third harmonic component is present in the voltage, that is ER or the pitch factor. In that case, the pitch factor will be modified like this: cos 3 alpha by 2. So to nullify this, make it equal to 0. 3 alpha by 2 is equal to cos inverse 0 means 90 degrees. So from this alpha will become 60 degrees. So in that case the alpha should be 60 degrees, means the second coil side should be at 180 minus 60 degrees, that is 120 degrees. The span between the two coil sides must be 120 degrees. In that case third harmonic can be nullified. So let me summarize once. So here we have seen what is the definition of short pitched coil, what and the definition of the full pitched coil, and the definition of the pitch factor, that is the vector sum divided by the arithmetic sum of voltages in the coil. And if the harmonics are present, how to nullify them also we covered, that is by adjusting the value of alpha it is possible to nullify the harmonics that are present in the alternator.